Hello and welcome everyone. So in this topic we will be continuing with the topic of trigonometry. So understanding trigonometry part 2. In this topic we will be dealing with what are angles, what are radians, and how the trigonometric values have been derived. Okay. So we will be starting with the topic with a very simple one. What are angles and what are radians. Okay. So to understand what are angles, so you know that angles are measured in degrees, right? Angles are measured in degrees, but there is also a base unit of angles known as radians. Understand this term, radians. And angles are always measured in degrees and also measured in radians, so you need to understand what you mean by radians. So why there is a need of radians? Understand, the angles are always measured in radians. Degrees have some sort of limitation. What is that limitation? We will see now. For example, you know that how to show symbolically 420 degree of angle. How to show it symbolically? What you will do what you will do on a basic level? What you will do? You will have some baseline like this, and this is the vertex, say O, right? Okay. So this is the vertex. How could you show 420 degrees? For example, 420 degrees is above 360 degrees, right? Maybe it will take a whole circle, whole round. Okay. Now how will you show? Like this. Okay. So this is 4 to 360 degree. Okay, right? And 60 degrees more, right? So this is how you will show 420 degrees 420 degrees of angle. Okay, this is the angular displacement. But what if I told you the angles is in say triple angle, triple value? For example, one hand this much degree. How can you show diagrammatically? It's very hard and nearly impossible when the angular displacement is much more. Okay, if the angular displacement is much more, it is very harder to show in terms of degrees, right? So this is the main limitation of degrees. So what we need to do, we need to convert degrees into radians. Understand guys, this is a huge misconception. The radians is the base degree. Understand it, is the radians is the base unit of angle. To measure angle, angles are always measured in radians. Understand this. This is a misconception. Why? Because in primary sector, in primary school, what we deal only with degrees, right? That's why we feel that the base unit of angles is degrees, but no, that's not the case. Base degrees of angle is radians. Why? I'll show you right now. Okay. So first of all, what we'll see, we'll see the symbols. For example, if any angle is measured in degrees, how will you show this? In the superscript, in the power, you take a small 0 or O. Okay. But in case of radians, what you will show, if the angle is measured in radians, in superscript, what we do, we put a small c over here. Okay. So this is how symbolic, this is the symbolic representation. This degree, you know it already because you are dealing with from your since your childhood. So this is radians superscript is small c. Okay. I hope you got this. Okay. Now the fact is how to convert this. Okay, how to convert this from convert degrees to radians. Okay, this is very important. So if this is x degree, you need to convert it to radians. You need to multiply with a factor of pi upon 180. So whatever answer you are getting is always in radians. Okay. So what are the tips? What are the What are the notes that you need to understand? The radians always comes in terms of pi. Okay, radians always comes in terms of pi. If the any angle is in radians, it will always contain this term of pi. Understand this. Okay, means if you are converting any value in radians, what you need to understand that this pi should not be converted into 3.14, should not be converted to 22/7. It should be left as it is. The best example, I will give a very best example, say 45 degrees. If you want to convert 45 degrees into radians, what you will do? Convert into pi by 180. So what will the answer I will get? That is pi by 4 radians. Are you following it? Okay. So whatever number which is provided over here, okay, we will be able to convert in terms of radians. But understand, radian always contain a term of pi. So no need to touch this value. don't perform any kind of function over here, that is convert to 3.142 or 22 by 7. Okay, no need to do such kind of thing. Okay, leave pi as it is, because the final value of radians always contains a term of pi. Okay, so note down this. Okay, very important. This is how we convert degrees to radians. Now if you want to do vice versa, what you need to do, say here, if you want to convert, okay, we are going on vice versa direction. If you want to convert radians into degrees, you need to take reciprocal of that. You need to take reciprocal of that value. So I will do 180 by pi, and whatever I will get the answer which is in degrees. See what I told you, radians always contains a term of pi. So the numerator pi and the denominator pi will get cancelled, and you will get a pi free value, that is in degrees. Are you following it? So again, a very best example, I will say pi by 6. Okay, so pi by 6 radians into, I will say 180 by pi. So pi is getting cancelled. 180 by 6 is nothing but, say 180 by 6 is nothing but 30 degrees. Are you following it? Okay, I hope you got this. So this is very important. Before studying trigonometry, you need to understand this conversion, degrees and radians. The guy studying in say technical sector, it is very important for you. When to take angle in radians, when to take in degrees. There is a lot of confusion between the students. Okay. So understand, whenever the angle, see, angle is always measured in theta. Okay, it's a Greek letter. When theta is alone, always take in radians. Understand this. Okay, and when theta comes with any kind of trigonometric ratio, say sin theta, cos theta, if any trigonometric ratio is assigned to with it, always take in degrees. Understand this, very important. This is very important tip. Okay, understand this. When theta is alone, when nothing is there with the theta, always take the angle in radians. If there is a trigonometric ratio assigned with it, always take in degrees. Okay, so this is a very basic tip, you can remember, or you can write it down, and very important in examination. Okay, now coming back to the trigonometric values, very important, guys. What students try to do, trigonometric value, what students try to do, they try to mug up each and every value, trigonometric values. Okay, what they try to do, they try to mug up each and every value. That's what, it's not needed. Okay, so these are known as terminal values. Okay, 0 degree. Okay, then 30 degree. Then I will write this here, pi by 6. I am also writing in terms of radians. Then 45 degree, that is pi by 4. Then 60 degree, that is pi by 3, and 90 degrees, that is pi by 2. Okay, so understand, if you want to convert this pi into degrees, pi means how much, what can you understand? Pi means 180 degrees. Understand this, very important. Okay, it's obvious, no need to explain, it's obvious. Okay, so here I will write sine, cos and tan. Okay, sine, cos and tan, very important, guys, understand. So what students try to do, the basic mistake they perform is what they try to do, they try to mug up each and every value. Okay, absolutely no need to mug up each and every value. What you will see, there are certain tips to understand this value. You need to just keep in mind the first row of the sin theta. So what is the first value? Sin 0, 1 by 2, 1 by root 2, root 3 by 2, and 1. Okay, so just remember this first row. It is a very primitive manner, guys. You can also derive each and every value, that is each and every terminal. Okay, getting it? So, but to keep the simplicity of the subject, what you need to do, you need to keep in mind the first row, 0, 1 by 2, 1 by root 2, root 3 by 2, and 1. So for cos, you need to reverse the order of sign. So 1 will come here, 1 root 3 by 2, 1 by root 2, 1 by 2, and 0. Are you following it? What I have done, I have just reversed the order. For tan, what you need to do? For tan is nothing but sin by cos. Okay, tan is nothing but sin by cos. So 0 upon 1. So here I will say 0. Here I will get root 3. Here I will get 1. Here I will get 1 by root 3. Right? And here I will get 1 by 0 is infinity. Are you following it? Okay, it's very important. Again, this sine, cos and tan. I have got these three basic ratios. Now I'll go for the ratios which are reciprocal of it. Okay, I'll go for the ratios which are reciprocal. So cosec theta. So what do you mean by cosec theta? Cosec theta is nothing but reciprocal of sine theta. So what I can do? I can take reciprocal of sine terms. So reciprocal of 0 is infinity, means 1 by 0 is nothing but infinity. 1 by 2 is 2, 1 by root 2 is root 2, 2 by root 3, here I get 2 by root 3, and here 1 reciprocal is again 1. Okay, are you following it? Keeping things much more simpler. So sec theta, so performing the actions for sec theta you can do by two ways. You can either reverse cosec theta or either you can reciprocal cos theta. Okay, you can perform any one of the methods, you will get same answer. Okay, so here I will get 1. Okay, here I will get root here I will get root 3 by 2 by root 3. Okay, here I will get 2 by root 3. Okay, here I will get root 2, here I will get 2, right, and cos here if you take reciprocal of 0 I will get infinity. Are you following it? Okay, it's very very simple. And next the final term is cot. Okay, again cot, how can you perform cot? Okay, cot there is two ways again for cot. You can either take reciprocal of tan or you can either divide cosec upon sec. Okay, so any one of the method will be implemented, not an issue. Okay, so cot 0 will be infinity. Okay, here I will get 1 by root 3. Okay, here I will get 1. Okay, are you following it? Here I will get root 3 and here again I will get infinity. Okay, so this is how you should derive each and every values of trigonometric ratios. Okay, so this is the chart you can prepare. If you practice 1 to 2 times then not an issue. Guys, this is not applicable for guys who are at higher levels, because calculator is allowed at higher level. This is for secondary and intermediate level where calculator is absolutely not allowed. Okay, so for manual calculation you need to understand this technique. Okay, but now the major doubt that arises, that what happens when the angle crosses 90 degree, right? What happens when the angle crosses 90 degrees? See guys, so for that you have a very very basic and very very important important topic you need to understand, is what you mean by allied angles. Okay, this is a very vast topic, allied angles. If you understand this, no need to mug up any kind of formula. There are factorization, defactorization, double angle, triple angle, negative angle, all formulas are derived in terms of allied angles. Okay, getting it? What you mean by allied angles? I will just give a brief view of it. I can't explain it more because I am going to take a separate lecture on allied angles in the part 3. If you want part 3, you can comment in the comment box. Okay, so what are allied angles? For example, say if I want angle say sine 120. Okay, if I want angle sine 120. So if I have any angle, what I will try to do, I will try to find out the terminal angle, which is the terminal angle close to 120, say 90 degree. I know the value of 90 degree. So what I will do, I will write in this term, sine 90 plus say 30. Are you following it? And then I will derive its value, sine 90 plus 30. Okay, getting it? So this is known as allied angles, where what you do, theta plus minus x. Okay, this is known as allied angles. If you want a separate lecture, I am going to take separate lecture on this. It's very very important. If you understand this, no need to mug up any kind of formula. Okay, there are 100 to 150 formulas of trigonometry, or factorization or defactorization. If you understand what you mean by allied angles, then it is very easy for you to perform. Okay, so I hope you understood this lecture. It was very basic way to remember what the trigonometric ratios. You can perform this. You can use these trigonometric values at a very basic level. For example, you can solve the application level sums. what are the applications of trigonometry. Okay, the sums can be either in terms of, say, looking the statue at the statue over a statue, or statue over a platform, or statue below platform. Okay, you are walking, you have to find the angle of, say, kite or whatever. So the simple application you can find in the intermediate grade and secondary grades. Okay, and you can also use this by solving some performing some simple algebra. Okay, so I hope you have understood this. We'll be dealing allied angles in the next lecture. You have If you have any doubt, you can mention in the comment box. Thank you very much. Have a great day.